Hello, mathematicians. When you have mastered addition and the concepts of difference and distance, then you are ready to put it all together. When we put it all together, we get additive thinking. In this video, we'll learn about additive thinking and the special role that subtraction situations play in additive thinking. Before we begin, it's only fair to warn you that there will be a lot of vocabulary in this video. When you are first learning the vocabulary of additive thinking, it can be pretty confusing. But if you power through and clear up that confusion, then it will be gone, and addition and subtraction will make much more sense to you. If you don't power through and clear up that confusion, then it's going to keep following you, and every time you find yourself in a situation where you need to use additive thinking, you're going to be confused. So let's get started. When we talk about additive thinking, we're talking about the first of the three basic operations in mathematics. In this operation, we begin with an initial quantity. The technical terminology for the initial quantity is augend. We're going to call this part and let P stand for part. The initial quantity, officially the augend, is the first part of the operation. Then there is a change. There's something different. The official terminology for this different quantity is addend. We're going to call this the difference. So we have a quantity which is the initial part, and then to that is added a different quantity. That gives us a new quantity. The technical terminology for the new quantity is the sum. We are going to call this new quantity the whole and let W represent the whole. So the initial part plus a different quantity gives us a new whole. In more official language, we would say augend plus addend equals sum. It's important to understand that within this new sum, or this new whole, we still have the initial part and the different part. So let's think about how these parts relate to the number line. The first number that we could read from the number line would be right here. What would this number be? This number would be P. Because we're starting at 0, and this is the initial part, then P would be right here on the number line. The next number that we could read off the number line would be right here. What would this number be? This is a little trickier, so pause the video for a minute and think about it. If you're working with someone, talk about it. This number would be W. Did you think that this number was going to be D? Well, actually, D, the different part, cannot be read from the number line. The different part is this quantity between P and W, between the initial part and the whole. So since we can read P directly from the number line, we don't really need this quantity in our model, so we can remove that. And now we have part plus difference equals whole, or officially, augend plus addend equals sum. So here is the big question. If the different part cannot be read directly from the number line, then how do we know what it is? Pause the video and think about it. If you're working with someone, talk about it. We can find D, the different part, by calculating the distance from P to W, or the distance between P and W. And we know that to calculate distance, we use subtraction. So to find D, we subtract the part from the whole. We subtract the part from the whole. And that gives us the difference. Now, in case augend, addend, and sum weren't difficult enough to remember, for some reason we get a whole new set of official terminology when we're talking about this same additive relationship in subtraction terms. Now, the augend or part is called a subtrahend, and the sum or whole is called a minuend. One little bit of good news is that the difference is actually called the difference in the official terminology. So we have minuend minus subtrahend equals difference. But we could just as easily have said sum minus augend equals addend, because they are exactly the same quantities. So really, the official terminology may be a little bit more confusing than it needs to be. So to simplify our additive thinking, we're going to use the terms part, difference, and whole. Part plus difference equals whole. Whole minus part equals difference. This special relationship between addition and subtraction is called an inverse relationship. We say that addition and subtraction are inverse operations. You will probably hear people say that inverse means opposite, that addition and subtraction are opposite operations. But inverse does not really mean opposite. Inverse comes from the word invert, which literally means to turn something inside out. It's like if you're wearing a t-shirt and you take it off and turn it inside out and put it back on. It's still the same t-shirt. You just turned it inside out. Subtraction is actually the same operation as addition. It's just turned inside out. That's why when we are talking about additive thinking, we're talking about both addition and subtraction. Now that we have learned about additive thinking and the special relationship of addition and subtraction, it's time to use additive thinking to solve some problems. We can categorize additive thinking problems into three main groups. In the first group of problems, the different quantity is combined with the initial part to form the new quantity. In the second group of problems, the change is that the difference is removed or separated from the whole, and it leaves the first part. The third group of problems is very important in the real world. In these problems, we are comparing a larger quantity and a smaller quantity. We'll also look at problems that are a little bit different because they don't really involve a change. Instead, they involve a part-part whole structure where we need to find either the whole or one of the parts. So mathematicians, now that you have learned about additive thinking and the special relationship between addition and subtraction, it's time to practice using additive thinking to solve some problems.